Hi, this is Krishna Karthik presenting you the demo for Challenge 2 of EC 561. The agenda for the demo is the following. It is to present a home monitoring system using MSP432 P401R with Educational Booster Pack MK2. The system consists of a continuous monitoring of and a response to a doorbell press, burglar activity, and a fire. The events associated with these activities, respectively, should be a button press for a doorbell, a loud sound above a certain threshold indicating a burglar activity, and a light intensity above a certain threshold indicating a fire in the home. Now, let me walk you through the user interface requirements for the system. Every time the doorbell is pressed, the system consisting of the MSP432 and the Education Booster Pack should output a sound that emulates a real doorbell for about 2 seconds. Furthermore, as a single button press other than the doorbell press should activate a burglar alarm. When the burglar alarm is activated, the RGB LED should be red and it should be green when the burglar alarm is deactivated. On a system reset, it should be deactivated. In the event that the sound threshold is exceeded, for example, a glass shattering, while the burglar alarm is activated, then the system should output a sound that emulates a real burglar alarm until the deactivation button is pressed. There should be no burglar alarm sound when the burglar alarm is in the deactivated state. In the event of a light's intensity threshold is exceeded, that is, in the case of a fire, at any time, this indicates the highest priority over the burglar alarm as well as the doorbell. Then the system should output a sound that emulates a real fire alarm sound until the system is reset. Let me now walk you through the structure of my code and help you understand how exactly my code captures the specifications that are laid out for the home monitoring system. As a first step, I've made an effort to write a modularized code for the home monitoring system. My first function would be to enable hardware system reset on pressing the S2 button, that is the port 1.4 in the MSP432 board. As a next step, I have configured the timer A module in an up mode. This is to realize a pulse width modulation signal for the buzzer, and I've used this pulse width modulation with different duty cycles to emulate different sounds. For example, a real doorbell, a real burglar alarm, and a real fire alarm for different stimulus to my home monitoring system. As a next step, I have written the port initialization function. That is, I've enabled the port 3.5, that is the S2 button in my booster pack, which, and on pressing the S2 button, the doorbell sound is emulated. And I've initialized the port P5.1, that is the port S1 in my booster pack. This is to enable as well as to disable the burglar alarm. I've made the port 1.4 as a hardware reset button. This is to reset the MSP432 and the booster pack system to initial conditions. Now, as a next step, I've written a function to initialize the red and green LEDs. As you can see, I've initialized the green LED to a high and a red LED to low. This is because the on the green LED being a high, this indicates the burglar alarm is deactivated. On the red LED being on a high, it indicates the burglar alarm being activated. Okay, now as a next step, you can see that I've written a function to handle the sound system for the fire alarm, and inside the function, I've varied the duty cycle for the PWM output of the buzzer, and through this, I have tried to emulate a real fire alarm whenever the light intensity exceeds a particular threshold. As you can see over here, I've written a function. I've called the function safety reset. This is to ensure that on pressing the reset button, in the MSP432 board, that is the S2 button, my system gets resetted and the fire alarm would stop. And as a next step, I would have written the function for handling the doorbell sound system. And inside the doorbell sound system, I again check if the light intensity exceeds a particular threshold for the fire alarm to be executed. And I also again vary the PWM duty cycle to emulate a real doorbell sound. And as a next step, I also have written a function for emulating a burglar alarm. And this function will get executed only when the digitized value is greater than a particular noise threshold, as well as when the burglar alarm is enabled. And I have tried to vary the time period and the duty cycle of the PWM to generate uh, a burglar alarm sound. And also in this function, I've called this function safety reset in order to reset the system back to initial conditions on pressing the S2 button in the MSP432. Uh, and I have also written a function for to initialize the clock configuration for the MSP432. I've initialized with a 48 megahertz clock, and I've written a function to set the GPIO configurations. That is the port 2.7 for the buzzer, and the port 4.3 that will serve as an input port for the that is the microphone for the burglar alarm. And I've also written a function to initialize I2C communication. And as a next step, I've written a function for to set the ADC configuration, that is the ADC14 module in my MSP430 board. I have enabled the ADC in a single conversion mode with AVCC as a reference, and I've enabled the sample timer in manual mode with interrupts. This is to ensure that we don't keep polling for the burglar alarm when the ADC digitized value, the sample digitized value is above a particular threshold, the burglar alarm will get executed if the burglar alarm is activated. And then I have written a function to enable ADC interrupts. Now let's see the main function. As a first step, I've initialized the input ports, that is the button for burglar alarm enabling, disabling, and the button for doorbell, as well as the hardware system reset. And now I go into my function for initializing the red and green LEDs, and then configuring the clock, and then initializing the I2C communication, and then initializing my digital ambient sensor, that is OPT3001, and then configuring the ADC and enabling the ADC interrupts. Inside my while one loop, I check, I get my lux value from the digital OPT sensor, and then I trigger my ADC initial conversion and store the digitized ADC value in ADC result. And as a first step, I check if my lux value is greater than a particular threshold. And on being greater than a particular threshold, the fire function is called to emulate a real fire alarm sound. And I also, as a next step, I also check if my doorbell button is pressed. And on pressing the doorbell button, the doorbell sound system is emulated. And as a next step, I check if my S1 button, the button for activation deactivation, is pressed. If it is pressed for the first time, then my flag that is initially would be declared as 0 would become this part of the if loop gets executed, and my red LED would be switched on and the green LED would be switched off, and my flag would become equal to 1. And on the next time this button is being pressed, the red LED would be switched off and the green LED would be switched on, indicating a deactivation, and flag would become 0. Thus I can remember the previous state through a software flag. And I delay for 10 milliseconds until the next ADC sample. Let me walk you through the biggest challenge that I've faced in this project, that is the function body for an ADC interrupt handler. The ADC interrupt handler's duty is to check if the ADC result is lesser than the threshold value or it is greater than the threshold value. If it is lesser, then don't do anything. But if it is greater, and if the ADC, if the burglar alarm is activated, that is being indicated by the flag being set equal to 1, Then inside this while loop, you again check if the light intensity is above a particular threshold by getting the value from the digital sensor. And then if it is above a particular value, you try to emulate a real fire alarm. This is because the fire alarm has higher priority over all other alarms, including the burglar as well as the doorbell. But if the button that is corresponding to deactivating a system is pressed again, then flag is made equal to zero. That is it comes out of this while loop, and the corresponding LEDs are set. And then if there is no button that is pressed, then the burglar alarm system is being activated. Let me now show you how the code is being flashed onto the MSP432 board as well as the booster pack that is connected to it. Now you can see the code getting flashed onto the board. It's getting loaded onto the board. Yes, now it's loaded. Let me now walk you through the hardware user interface requirements of this board. Now you see the S2 button right over here. On pressing this button, doorbell sound will be emulated for about 2 seconds. Let's press this. Every time you press it, you hear a doorbell sound. Now we see a green LED blinking over here that indicates the burglar alarm is not activated. If I go and shout near the board, the burglar alarm will not be emulated. Hello, hello, hello. No, it's not activated. So to activate the burglar alarm, I have to press the switch S1 that is right over here. On pressing the switch S1, the red LED is indicated, indicating the burglar alarm is enabled. Hello. Now, since we have enabled it, the red LED indicates that the burglar alarm is enabled. Now that the burglar alarm is enabled and it's emulating a real burglar alarm sound, to stop it, we need to press the S1 button right over here. As we press it, it gets turned into a green. Now if we start shouting it, hello, 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 the burglar alarm sound will not be emulated. Let me now walk you through how the fire alarm is being emulated. Now we don't hear any fire alarm from the system. In order to hear fire alarm, the light intensity has to increase. So let me now bring a mobile phone with a torch near this. Now you see, as soon as I brought a mobile phone with a torch near the system, you see a fire alarm being emulated in the MSP432 system. Now you hear a fire alarm through the system, and the only way to stop the fire alarm is to press the reset button. Even if you press the doorbell right over here, it's not going to stop. And even if you go and shout near the board, hello, 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 it's not going to give the burglar alarm because the fire alarm is the highest priority. And the only way to stop it is to press the reset button. So the S2 button of the MSP432 board. So let's go and press the button. Yes, now it has stopped the fire alarm. Let me now walk you through the most difficult part of this project, that is to set priority of the fire alarm over the burglar alarm. Now you see the burglar alarm being emulated. If there is an increase in light intensity, that is, I'll bring a light intensity, then the burglar alarm must change itself to a fire alarm. Let me show it in the right angle near the sensor. Yeah. Now you see, now you hear a fire alarm being emulated instead of a burglar alarm. And you see that there is a red LED is still blinking. Now, in order to stop the fire alarm and also to bring the red LED to green LED, that is to deactivate, bring back the burglar alarm to a deactivated state, you need to press the reset button. Let's press the reset button right now. As we press the reset button, red LED turns into green LED. The fire alarm is also deactivated and the burglar alarm is also deactivated. Now let me present the priority of burglar and fire alarm over the doorbell. Hello, hello, hello. Now you see, even when I'm pressing, when the doorbell is being emulated, if I make a sound that is greater than the threshold, the burglar alarm is being emulated. Let me now show you the priority of fire alarm over the doorbell. Let's press the doorbell and bring the mobile phone near it just after I press the doorbell. Now you hear that. Now for the first 2 seconds, we heard the doorbell, and after that, we heard the fire alarm. That's because the fire alarm is a higher priority. As a static implementation measurement feature, I'm showing you the graph between speed versus code size in bytes. I have implemented my project using recommended settings of TICCS. As a pre-compile optimization option, I've made all my functions inline to save the excess time in calling the functions. As a dynamic implementation measurement technique, I'm right now showing you the energy trace profile that is giving me energy, power, min, max, voltage, current, and estimated battery life for my project. As an implementation related optimization feature, I've incorporated the use of low power modes between successive ADC sampling. This is also an advice that CCS gives. Thanks for watching.